For the second portion of this lesson, we're now going to look at how to solve quadratic inequalities, which can seem really intimidating, but we're still just going to use a lot of the same skills that we know about inequalities in general, but more importantly, the things that we know about quadratic equations. And we're just going to follow the steps that are laid out here so you can see how this works. First off, we're going to make sure that we rearrange it so that everything we have on one side is in the standard form of a quadratic, and the other side is equaling 0. Then we're going to try and find the zeros, or in other words, find the roots of that corresponding quadratic equation. Now, from there, if this whole thing ends up being less than 0, if our original statement tells us that that quadratic is less than 0, then the solution that we're looking for, all of the possible x values that work, are all the x values that lie in between the zeros. So that's important to remember. If our quadratic equation is supposed to be less than 0, then once we find the roots, or the 0 values, our solutions will be in between those values. But if our quadratic was meant to be greater than 0, then the solutions that we want are outside the zeros, and I'll show you on a little graph that we sketch out how that works. And again, when I say graph, I don't mean a full x and y coordinate system, I mean just along a single number line of x values. So let's look at one like this first. Well, we already have it in essentially a standard form on the left side and 0 on the other. And specifically, it's supposed to be less than or equal to 0. Well, our next goal is to try and find the zeros of the quadratic stuff that we have on the left. Well, we can do that by simply factoring it. X minus 4 and x plus 1 would work in this case. And that's less than or equal to 0. So, in other words, the zeros are x equals 4 and x equals negative 1. Those are our two zeros. Then our last step says that if the quadratic that we're interested in is supposed to be less than, or in this case less than or equal to 0, then the solution that we want is all of the x values that are in between the two roots, or the two zeros that we found. So I'll just sketch out a little line here. It's like my x-axis. And somewhere along that x-axis, let's put a negative 1. A little bit farther down, we'll show where 4 is located. And we note that, once again, just to really emphasize this, the whole thing was less than or possibly equal to, which means it could be equal to those zeros themselves. It could be equal to 4 and negative 1. So we can actually put full solid dots on those points at 4 and negative 1. But because the rest of it needs to be less than 0, the way we satisfy that is by taking all of the x values that are in between those roots. So again, if we're looking for our quadratic to be less than 0, then we want our solutions to be in between the two zeros that we find. Let's try another one. For this one, we don't have to do any trinomial factoring. We can actually do common factoring instead. So if we common factor out a k, it would be k times a factor of k plus 5. And that's got to be greater than 0. That's the idea. So now the zeros come from those two factors. So either k could equal 0, or k could equal negative 5. Let's make a little line for ourselves. I'll put 0 maybe right about here. Actually, put 0 down here so I have more room, and put negative 5 down somewhere over here. But we want our quadratic expression that we have on the left, we want it to be greater than 0. And our rule that we have above says that if our quadratic expression is meant to be greater than 0, then all of the x values that satisfy it are outside of the zeros. And in this case, it's also not equal to 0 either. So it's not going to include our actual root values. It's not going to include 0 or -5. So because it won't include those, I need to start each of them off with an open circle. And then what we mean by the values we want are outside, well, it means it extends in this direction and it extends in this direction. So in other words, it's all values from just below -5 and then less than that, and all those that are just slightly more than 0 and more than that. So they go off in that direction, and those are all the possible values along our, if you want to think of it as a k-axis, that would satisfy that inequality. So again, we're just factoring and solving for the zeros or the roots or solutions, whatever we want to call them, based on skills that we know about quadratics in general, and then just following the rules laid out in these last 2 bullet points that tell us whether or not our answer is between the zeros or outside the zeros. Let's try this one now. Well, for this one, if we want to, we can do a little trick and divide everything on both sides by 2 to simplify it a little bit. So we end up with k squared, or actually I'm going to, divide it by -2 to make it even simpler. So I will end up with k squared minus 9. But because I'm dividing everything on both sides by -2, it's still going to be 0 on the other side, but it's going to flip the inequality symbol. Now that was a really useful step for me because now I can factor this by difference of squares. And there actually are other ways that you could have solved this. You could have actually just solved it by rearranging and taking square roots, but the factoring form is sometimes a little bit clearer to see the solutions. So this would be a difference of squares. It could be k minus 3 and k plus 3, but all of that has still got to be less than 0. Overall, our 0 points, or our roots, or our solutions, whatever we want to call them, would be k equals 3 from the first one, or k equals -3 from the second one that I wrote down. And we recognize that after that work that we did, all of this factored form needs to be less than 0. And so because the quadratic that we ended up with has to be less than 0, the values for k that we want are going to be in between our roots. So we can draw out a little k-axis once again. And I'll put maybe -3 down here somewhere, +3 up here. And notice that it's not going to ever be equal to 0. So I need to put open circles at -3 and +3, but it's going to include all of the values in between those as long as they're just slightly bigger than -3 and at least just slightly less than +3. And let's try one more of this type. So now I've got definitely a quadratic situation, but it's not really in any sort of standard form on the left side. So I'm going to add 5 to both sides. And remember, when I'm just adding something to both sides, that doesn't change the inequality symbol. So now it's just less than or equal to 0. What I can do, though, to make this easier to factor from here is deal with this negative. I can divide everything on both sides by -1. Now what that's going to do, of course, is just flip the signs of everything that I have on the left, like so. But it's going to change my inequality symbol. Now I divide the right side by -1 as well, and I still get 0. But the important fact is that I had to change this inequality symbol because overall I'm dividing both sides by -1 from there. But now I can factor this. This would factor into 2x plus 5 and 2x minus 1. And that's still got to be, in this case, greater than or equal to 0. So from there, I can figure out that the zeros would be, well, if I rearrange each of the factors that I have inside of those brackets after making them equal to 0, I would say that x could be -5/2. I would get that from the first bracket. Or x could equal +1/2. That's what I would get from the second bracket. So those are my roots. And if I look carefully, once again, I know it has to be greater than 0. So, or I should say greater than or equal to 0. So -5/2 and +1/2 are values that are included as part of the solution. So when I do my number line, I'm going to put solid dots in those places. But then because it needs to be greater than 0, I use the rule that says all of the other values I'm looking for are the outsides of those 0 values. So this is like my number line to represent an x-axis. I'll put -5/2 maybe somewhere around here. And I'll put +1/2 somewhere around here. And I'm going to put solid dots on each of them because in this case, it's actually okay for us to be equal to 0. But now from there, the rest of the x values that we want are on the outsides of those roots. So in other words, everything that's less than -5/2 and everything that's greater than 1/2 from there. So they go in that direction. So again, you're really seeing, hopefully at this stage, that it's all still relying mainly on quadratic skills, specifically factoring and rearranging of quadratics to find their roots. But then once we find their roots, it's just an additional couple of rules that we have to remember that are listed here in these final 2 bullet points. So if the quadratic expression that we factored should be less than 0, then all the x values or variable values we want are in between their roots or their zeros. If it's supposed to be greater than 0, then all of the solutions we want are on the outside of those. Get as much practice with this as you can. And again, really make sure that you're connecting this back to solving equations, whether they're linear or quadratic, because you're seeing now that the skills are very similar.